and 1 bit we have something called bottom of stack. Bottom of stack means right now it doesn't make much sense in your MPLS only, but when you do MPLS VPN, it start making some sense. L2 label, and this is L3, right? So right now your MTU is, see, when you put an MPLS label, your MTU also increase. By default, 1500 Ethernet will become 1504. Plus here bottom of stack is equal to 1. Here it doesn't make much sense. When you will open the header, here in the label it is written bottom of stack equal to 1. Now, we will talk about MPLS VPN. This is the concept which I'm learning right now called MPLS only. Other concept is MPLS VPN, which we will go to next. In this, we have L2, we have label, and L3. And here you have two label concept. So your MTU will become 4 plus 4, 1508. So here bottom of stack is equal to 0. Here bottom of stack is equal to 1. Okay. So here your bottom of stack will become 0. Bottom of stack equal to 1. This label has some different meaning. Okay, this label is used for what this label is used for, what we are using for this label, your push, swap and pop. Second label has different meaning. Okay. Likewise, if you will learn service provider, there you will learn traffic engineering. So you have L2. Label, and L3. Okay. Here bottom of stack is equal to 0, bottom of stack equal to 0, bottom of stack equal to 1. So again here we have three labels. This is called MPLS traffic engineering. MTU will be 1512. So here in the first, second, third scenario. In second and third scenario, it makes some sense. Your syllabus is still second scenario. First and second. Third you will do in the service provider. Okay, so first always this label will be removed. Bottom of stack, top will be removed first. Bottom of stack 0. The way we start from here. First this remove, then this remove, then this. Here first this remove and then this remove. Here it doesn't make much sense because you have only bottom of stack equal to 1 only. You have only 1. Okay. So in your second concept, when we complete MPLS and then we jump to MPLS VPN, I will teach you about bottom of stack also. Another bit is called 3-bit. Like in quality of service, we have learned experimental bits like marking bits. Same thing here. Quality of service, where we do traffic engineering. One of the thing of traffic engineering is when you put QS, this will come in the picture. So here also it will come. 3-bit, they have their own QS field, marking field only, 3-bit. And then I'll let you know a little later. There's some variation in 8-bit field called TTL. The way we have time to live. Same concept is here, but here some issues will come. So I'll show you how to resolve that issue. So here I'll put a start. At this topic, we're going to do it a little later. Maybe tomorrow or maybe after tomorrow. Most probably tomorrow. Today I will take a spot. Now tomorrow I will be on time. So this is about your 20 bit, 32 bit, 21, 24, 8, 32 bit. So first 20 bit is label, 1 bit is bottom of stack. This is equivalent to your marking bits, and this is your 8 bit TTL. Now, if we'll talk about in MPLS, as I have told you, if MQ is 1504 after adding an MPLS label, then we need fragmentation, right? So on router of MPLS router, they have a concept called path MQ discovery. Like normally in CCNA, when we studied TCP header, there we teach in in IPv4, there's something called IP path MQ discovery. Actually, what it will do, when it negotiate the minimum MQ in a path. So these are the probes which use something called type 3, which is destination unreachable, and we have port 4. Here what will happen, DF bit is equal to 1. So this probe will use this ICMP packet. Okay, so what happen is they are sending a packet here. Suppose I have to negotiate a minimum MQ in a path. Suppose this has a 1300 MQ. Now when my 1500 will go inside 1300, what will happen here? Problem is, he will say that I cannot see. DF bit means do not fragment. When you will learn, you have to revise your CCNA. IPv4 header, we have more fragment, don't fragment bits. So when don't fragment bit is enabled means we won't do any fragmentation. So what will happen? This probe will go and packet will drop. When packet will drop, this type 3 code 4 is generated, plus it will tell the MQ of who dropped the packet, his MQ will be written. So what he will do, he will manipulate his MQ to 1300. So they are negotiating. They are negotiating on what they do not want to do fragmentation. If you do not want to do fragmentation, then they will negotiate with the path MQ discovery with the lowest MQ in path. Okay, this is your router concept. The problem is, suppose if in interview they can ask you, what if a switch is in between? See, switch does not support path MQ discovery concept. Switch does not support path MQ discovery concept. So for switch, what you have to do is you have to change because it support only 1500. If MQ is 1504, switch won't discover to participate in path MQ discovery. So here under the switch we have to go and we have to type a command called system MQ 1504, or this is like called jumbo frame. You will different ways to enable on switches, like on the global configuration mode, system jumbo frame command. Okay, or you can go to interface VLAN, suppose SPI interface, and type MQ command, or on the global what I've told you, system MQ command. It's up to you. Okay, so this is how you have to manipulate. Other thing is a question they ask in MPLS: is there any loop in MPLS? Okay, the answer is there could be, but MPLS does not have any loop. See, before running MPLS, we have to run routing protocol like OSPF and ISIS is the most popular protocol which are running over a MPLS topology. So if a routing has a loop, now try to understand, if a routing has a loop, then only you have a loop in MPLS. Otherwise, again, I'll make a note for you guys. If you have loop in routing, then you have loop in MPLS. MPLS cloud. Otherwise, there will be no loop. Okay. Another concept is, today I'll give all these small things. Your labels. When you assign labels, we can assign in two different ways. One is called per platform. Other is called per interface. Now, per platform meaning, suppose in your routing table you have 10, 11, 12, 13 routes. So actually what it do is, we have like whatever is there in your routing table, a lib table, what it will do, it will create, it will take all your routes and assign labels to your route. Just an overview I'm giving. This is called per platform. Okay. So here it will give sequence of labels. In per interface, we have route 10, 11, 12, and 13. Okay, maybe you have learned this on F0/0, F0/1, F0/0, F0/1, F0/0, F0/1. So here per interface means 16. Again, F01 is new interface 16. 17, 17. 18, 18. Likewise. If you want me to do 16 also, F0/0, 19, 17, F0/0, 9. Likewise, they assign labels. Okay, per interface. So here the concept is, if you have a network more than 2 raised to power 20, then use this per interface. By default, per platform. If you have a network more than 2 raised to power 20, then use. Okay. And other thing is, as like in your frame layer you have studied that densities are locally significant, we can also say labels are locally significant. Labels are locally significant. Meaning, if this router has assigned any route to 16, maybe this router will also assign this to 16. So it should be unique at your own routing table labels, but it should be same on the other router. So that's why it is called locally significant. An example, if I'll give you, we have one thing called routing table of MPLS is called LFIB table. So how it works, it has like, when you open LFIB table network, your in label, your out label, and your router and next hop, lot of things are there. And an exit interface, so all information is there. Suppose he's saying that 17.0.0.0 in label is 16, out label is 16. And it will be R4, next hop is 10.1.1.2 0/0. Meaning, if anyone will come with a label 16, swap it to 16. So it could be possible that you are swapping to the same label because it's locally significant. Okay, these are some important points on your, for your like MPLS, which you should aware. One, we have seen that they push pop concept. Okay, and now these are the basic thing. Now the important part which we will do next is, we'll learn about lib table, we'll learn about LFIB table, we'll learn about LDP, we'll learn about TDP. Okay, and then once we will going to learn and structure what is lib table, LFIB table, then only we can learn about PHP, penultimate hop pop. Okay, so as an introduction, I'll just give you a few more things, then we'll continue tomorrow because I have less time. So first of all, if I will tell you like normal general question, like first of all, this you have like layer 2 MPLS also, which is called L2TP channels are there. Now these are layer 2 MPLS because like they are connected like this 10.1.1.1 and 10.1.1.2. So MPLS, when you will learn service provider completely, you will learn about L2 also. Okay? And like in frame relay, it is like different variants are there, hub and spoke and all those topologies there. Here we have always fully mesh topology by default. Okay, suppose you got an internet connection. See, in a frame relay, what actually happen in frame relay, if you have to recall your CCNP classes, NA classes, NP, nowadays we don't even learn frame relay. So, if suppose you want like, uh, you want to communicate fully mesh 1, 2, 3, 4, 5, 4, 5, 6. Okay. Overall, like suppose you need 6 PVC, permanent virtual circuit here, which will cost you more. Okay, cost will be more. But in MPLS, just you are connected. Suppose normal, I'm telling you, so just a basic. If you are connected to an MPLS, you are by default fully mesh. Fully mesh, you are paying for one connection, getting fully mesh. So here cost is less. Because suppose this is an internet connection and you are connecting MPLS, so you will get connectivity. That's your local understanding. Okay, so why everyone is using MPLS? That is the first reason. Okay, apart from that, how it works, that we have seen. Okay, so now the main thing again, just to recall. Let me recall that any small things are left. Okay, lib is there, LFIB only left. Fine. So we need to now learn. I'll just give you an overview, then I'll continue next time. Tomorrow will be on time. Suppose these are the topology. Okay. First of all, if you want it is MPLS cloud, see how the reachability will come. In the production, they are using OSPF or any IGP protocol. See, BGP you cannot use. Try to understand when it comes to BGP, you cannot use BGP because try to understand if you are learning OSPF. Okay, here in the routing table. To that O route or D route or R route, it can assign label. To the B route, BGP route, it won't assign label. So BGP we won't use for, see, it won't exchange label. That is the issue. BGP has one issue that it won't exchange label, but still I will show you one practical with core and P to C. There is a BGP running, how to manipulate. So that concept will come little later when we'll do MPLS VPN. A lot of concepts are there. So either you run OSPF, we will, in our example, I will go to run OSPF, which is the popular one. ISIS protocol is not there in the syllabus, so otherwise I should have taken that. Okay, so otherwise ISIS is again one of the good options. So OSPF, EIGRP, whatever you want to take. So what it will do, once OSPF will form neighborship and the connectivity is there, on top of that you have to enable your MPLS. So we have a concept of LTP, the label distribution protocol. So what actually it will do, it once your MPLS is enabled, it creates something called lib table, LIB table. Okay, lib table, what it will do, it will get the information from the routing table and assign labels, like the way I have explained you, assign labels to the route. And what they will do, LDP will form a neighborship. Then LDP will go for a neighborship, and when they will form a neighbor, when they exchange their LIB tables, see, during neighborship, they exchange their lib tables. When they exchange their lib table to each other, like a routing protocol will do, okay, they will going to form a routing table called, of MPLS routing table called LFIB. So always remember, it is similar concept like OS, like suppose what OSPF do. First they become OSPF neighbor, and then they start exchanging route. After exchanging the route, the best path will go to the routing table. Same thing here, LDP, first they exchange LIB table, so they'll find out they will merge it, and they will going to, I'll tell you that how many tables are involved to fill that LFIB table. Now this is the routing table of MPLS. So here we have to put more focus. Okay, so very basic part we have done in the last class and today's class. On the next class, what we have to do is we should know about what is LIB properly. We'll discuss what is LFIB. Okay, how it forms, what is the flow structure, I'll tell you, and LDP, and then one PHP concept. Then we can move towards the practical. Okay, today I'll stop here. Tomorrow we'll continue by time only.